Okay guys, we're going to talk about 8-4, angles of elevation and depression. Our objective, solve problems involving angles of elevation and angles of depression. An angle of elevation is the angle formed by a horizontal line and a line of a sight to a point above the line. For example, you've got this horizontal line, and if you go above that horizontal line, you've got this line right here. So angle 1 is an angle of elevation. Angle of depression is the angle formed by a horizontal line and a line of a sight to a point below it. So here's your horizontal line. If you go down, you've got this segment right here, so it forms this angle right here. So that is, angle 2 is the angle of depression. Since horizontal lines are parallel, so you've got this horizontal line, they are parallel. Therefore, you know that this angle of elevation and this angle of depression are congruent because of your alternate interior angles theorem. Okay, so let's classify here. You've got angle 1. Angle 1 is this angle right here. You've got a horizontal line. The point is below it, so this is angle of depression. Angle 4. Here's your horizontal line. You go up because there's your angle 4. So because you're going up from the horizontal line, this is an angle of elevation. Okay, see if you can identify these on your own. Alright, so let's apply this. The Seattle Space Needle cast a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? Round to the nearest meter. Okay, so I'm visual. I need to draw a diagram. So I'm going to draw the Space Needle. I don't know what Space Needles look like, but that's my Space Needle. It cast a shadow of 67 meters. So here's the shadow, and it's 67 meters. Okay, if the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees. Okay, so what that means is, here's your horizontal line. Angle of elevation means it goes up. So it's going to be this angle right here. And it's going to be 70 degrees. How tall is the Space Needle? So we need to find out what x is. Okay, so we've got an angle, and we've got a side measurement, and we're missing a side measurement. Okay, so how are these sides related to this angle? Well, we have opposite over adjacent. So what we need to start thinking is the tangent of this angle, which is 70 degrees, equals opposite, which is x, over the adjacent, 67. Okay, so x equals 67 times the tangent of 70 degrees. Key all that into your calculator. Don't round until the very end. And you should get approximately, round to the nearest meter, 184 meters. So, how tall is the Space Needle? Right there's your answer. Okay, now we've got an ice climber stands at the edge of a crevice. Okay, so here's the ice climber. The crevice is 115 feet wide. So here's the crevice. 115 feet wide. The angle of depression from the edge where the ice climber is standing to the bottom of the opposite side is 52. Okay, we're talking about angle of depression. So, here's my horizontal line. So we got to go down below it for depression. So what we're doing is we're looking at this angle right here. This angle right here is 52 degrees. Okay? Well, if this angle is 52 degrees, you should know what this angle is because they are alternate interior angles, so it is 52 degrees. All right, what are we trying to find here? How deep? We're trying to find how deep that crevice is. So again, we've got opposite over adjacent. So you have the tangent of 52 degrees equals x over your 115. So x is going to equal 115 times the tangent of 52 degrees. Key all that in your calculator. Do not round until the very end. And you're going to get 147 feet. And that is how deep the crevice is. Okay, an observer in a lighthouse is 69 feet above the water. Okay, so this is going to be the lighthouse. So they're 69 feet above. So this right here is 69 feet. Okay, because this right here is water. All right, he sights two boats in the water directly in front of him. So this guy is up here at the lighthouse. And he spots, let's do this for boat 1, and let's do this for boat 2. The angle of depression to the nearest boat is 48 degrees. So, angle of depression, we need to put a horizontal line up here. The first boat, which is the nearest, so this angle is 48 degrees. Angle of depression, boat 1. The angle of depression to the other boat, so to the second boat, here's your horizontal line. So we need to draw a line to the second boat, and we're talking about this angle. It is 22 degrees. What is the distance between the two boats round to the nearest foot? Okay, so let's call this segment Y, this segment X, and the total of X, Y, Z. Okay? Now, what's the measure of this angle right here? It's alternate interior to the 48. And then what's the measure of this angle here? It's alternate interior with 22 degrees. Okay, so to find Z, we have opposite over adjacent, okay? So let's find Z. So to find Z, we can take the tangent of 22 degrees and put it over 69, and then Z. All right, we need to cancel out your variable as the denominator, so we multiply both sides by Z. So what you have here is Z times the tangent of 22 degrees equals 69. Then we need to divide both sides by the tangent of 22 degrees. Tangent of 22 degrees. So Z equals 69 divided by the tangent of 22 degrees. Key all that in your calculator around at the very end, and you're going to get approximately 178 of a foot. Okay, so we have Z. Now we have Z, and we're trying to find out what this distance is. which we can't figure out yet. But what about y here? To find y, can you take the tangent of 48 degrees, which is opposite over y? Okay, when you cancel out this y as a denominator, multiply both sides by y, and then divide by the tangent of 48. So you're going to have 69 divided by the tangent of 48 degrees. Keep that in your calculator all together. Round at the very end, you're going to get 62 1/10 of a foot. Okay, we have z, we have y. So to find x, all we need to do is we need to take z and minus y, and it will give us x. So we said z was 178/10, y was 62 1/10. Therefore, x, round to the nearest foot, so we're going to say it is approximately 109 feet. Okay, we've got one more. This is exactly like number 5, and I'm going to let you all do this as a candy question. You need to remind me tomorrow. Show me your answer. As soon as you come in class, if you get it right, give me a piece of candy. Y'all have a good one.